And we're live with Margaret Warren. Margaret Warren is a longstanding, trailblazing innovator in the space of semantics and particularly image metadata. Margaret Warren is the founder of the Metadata Authoring Systems. She is also a principal consultant there, and she developed this wonderful semantic image annotations platform called Image Snippet, or Image
There's
Snippet.
snippets. Yeah,
Okay,
snippets.
plural.
Yeah.
Okay.
Yeah.
Um, so wonderful to have you, Margaret, and I'm so glad that you're here with this individual presentation and tomorrow with the panel discussions. I know you are teaming with enthusiasm to collide the minds in that one. Um, but yeah, it's always a pleasure to work with you.
Thank you. Thank you. Oh, it's always a pleasure to work with you too. So I really enjoy, you make everybody feel very comfortable and yeah, you do a great job working and you network everybody together and yeah, it's really good. I really enjoy it. So okay, so are we ready? Are we ready to start? All
Yeah.
right, here we go. We're off and running. Okay. All right. So, what I'm going to talk about is why can't I find the image I want? And this is a really complex issue because I'm sure everybody does Google searches and looks for images. But I just want to say, as part of my introduction, I just want to say a little bit more about metadata authoring systems. Basically, our primary objective is that we want the most obscure images to be findable and easily accessible by describing and preserving them in the most precise ways possible. And so I'm going to just launch right into this. So, from a research perspective, is how I'm going to approach this talk. And I'm going to cover a number of aspects of image description and search. And we're going to do it in a very short time. So, I'm going to get right to it. Okay, so this first image, I use this cute image of this bald eagle family illustration. That's what I asked for in Google, and I asked for that because about a week ago, I had seen someone use a real example, like a realistic, a photorealistic example of a generative AI image that was a bald eagle family, and it had tiny baby bald eagles with white heads in it, and which is not at all correct. Of course, most of us know that baby bald eagles do not actually have white heads. So, but this is just a cute and harmless, cute picture. But we know that every day there are serious examples of incorrect generative AI images that are being returned from for search results every day with more and more frequency. So, in fact, this was a Google search result. It did specify that it was from generative AI company Night Cafe, but I asked specifically for bald eagle family illustration, and this was one of the things returned on the top of the top results. So, it kind of goes without saying that some searches are better than others, and it may be a little bit hard to see some of these slides, but humans have had to learn a variety of search strategies based on all of the machine algorithms we encounter every day, and this has influenced our search behavior based, of course, on our level of media literacy, which is something a lot of the panelists here have touched on today already, and is really important. But most of our search habits have been learned around Google, of course, and on the other side, Google has learned from our search habits in this sort of bizarre symbiotic dance where Google tries to predict what we want to find alongside the profitability they can derive from the search results. So many are, geared towards, products as opposed to accuracy and things like that. Or, I think they want to provide both, but, sometimes we're not always looking for products. But as we all know, Google changes their algorithms. And so then content and SEO strategists have to figure everything out again all over from scratch. And they made a big change in March of this year. One of my first observations is that it seems to be returning more results from specialty forums and magazines and so on. So this was a good search for that. It's I searched for historically accurate photos of sports car racing in Nassau, Bahamas in 1952, because they used to do a lot of racing in 1952 in the Bahamas. So this is a very complex query, and while these results might not exactly be from 1952, they seem to be good leads that might take me down some fruitful rabbit holes. Of course, this is not guaranteed. And so one of the premises of this talk is that we have had the technology to get much better, much more precise results now for it easily over a decade, at least 15 years or more. But because the search works the way it does, other searches can be pretty abysmal. So this search, for example, was for Chinese American poets. And it actually doesn't reveal much at all. In fact, there's plenty of content on the web identified with Chinese American poets, but the search results here have taken us to the broader category of Asian American, or even Korean, Vietnamese, Japanese, or just Chinese, not Chinese American, in the top results. And they're just generally not very good. So in general, we can say that there is often much confusion in search results in what is known as the long tail. So the long tail is a power law concerning statistical distribution, where there are often many more occurrences far from the head of the distribution, but they can be much more difficult to access. In other words, there could be a lot of results for a simple search like 1950 Porsche automobile, because lots of pages contain that exact text, but not so many results the more complex our query becomes. When this happens, Google tries to predict things because it doesn't like to say it can't find anything. Although although it is funny when I get this result, it looks like there aren't any images that match on this topic, which is, an example of a false negative, when the search engine can't find anything, but those things actually exist. Versus the other example in the Chinese American, where there's lots of things you don't want. There's lots of false positives. So now I'm going to get into some deeper material, because with the introduction of LLM and generative AI technology in the form of ChatGPT, Google Gemini, Perplexity, etc., we now have an even more confusing set of conditions, especially when it comes to very context-dependent specialized knowledge. So it should go without saying that describing, finding, and making images are actually very different tasks, but that's not as obvious as it seems in practice these days. So as I said earlier, I happen to work with collectible car images a lot. So I want to run with a quick example here. I often work with subject matter experts who have to search for photos that might show parts on an image, for example, in context. So in this case, this is an engine from a 1960s era Porsche 356. I found it fairly easily, but I did have to scroll down about 3 to 4 rows of Google results, because I specifically wanted to find an image where I could pretty clearly see a part on the image called the intake manifold, which is this little tube part that I point out with the arrow here. Of course, I knew basically what I was looking for, but there was literally no good way to describe in a Google search query that I wanted an angle that would show me this part pretty clearly in context on the engine. But I did manage to drill down to find the image, and I can be reasonably sure this is correct, not only because I have some subject matter knowledge, but because also when I went to the source page, the text on the page says that it's an actual museum quality example of a factory Porsche 356 engine. Now, just a detail to note here, the image itself has no metadata attached to this actual image. It only has the image on the web page, and the only way we can be fairly certain what it is because of the text on the page next to it. But what I wanted to do next was to do a series of some tests. So I wanted to see what ChatGPT would do and get a reverse description of this image. Now, I'm not going to read this whole thing, but basically it can often be fairly surprising how well ChatGPT can describe things. The more research you do, the more you find that the responses are usually quite generic. They really can't get into specific context, things that you might really want to know if you're the one verifying whether an image is accurate or not. But in this case, it says it's an internal combustion engine displayed in what appears to be a museum setting. Okay, that's very good because it got that from the rope and how clean it is and so far. And then at the bottom, it does say that it's reminiscent of those used in classic Porsche models. It doesn't say which one. It doesn't go get more detailed to that. But it was quite good. It was still not bad. But here's where the conflicts arise. So is this a Porsche 356 engine? Is this image AI generated? So what this really is, just so you know in advance, is an image I generated using Google's ImageFX Image Labs. So it has all the classic earmarks that you might see in AI generated people. Instead of too many fingers, it kind of has too many weird pipes going in and out of not enough ports to match the pipes going in and out. So you don't really need to be very knowledgeable about engines to look carefully at this and see that many things are kind of wrong with it. But and it looks very different from the engine in this picture. Even from a side view, even from a different view, it looks very different. So but with this image, I asked ChatGPT, is this image AI generated? But ChatGPT rather confidently said that it showed an intake manifold for a Porsche 356 engine. So that's interesting. So I also asked Google Gemini, and Google Gemini said, well, I can't definitively say whether the image you sent is AI generated or a photograph. And then what's kind of a riot is that it also it gives you some things to consider to help you decide on whether something is AI generated. But it says ultimately the best way to know for sure is if an image is AI generated is to contact the person who created it. So I think everyone can get the humor in this when it comes to trying to track down who might have created or posted the image that you're finding in a Google search result. But here's what it really is. So this is kind of very tiny to read. I don't want to try to click off this and go to show you the results of this, but I will explain this in a minute. But basically, this image was made with Google ImageFX, Generative AI Labs. The prompt that I used to create it was an intake manifold for a Porsche 356, which would seem to indicate that ChatGPT at least was reading the description because it was in the description and it was embedded in the image in the description. And that's all I gave to ChatGPT. But also Google themselves had added 2 embedded fields. And that's what this picture to the left shows. This uses a tool that can show you what's embedded in an image. And they use the credit line made with Google AI. And they also used a controlled vocabulary from the IPTC news codes called trained algorithmic media. So they clearly specified this was AI generated, but Google themselves said they couldn't definitively say, which means they aren't looking at their own metadata. But ChatGPT seems like it must have had to look at some of the metadata, because otherwise I have no idea why it would have guessed that it was an intake manifold for a Porsche 356 engine. So, this is just, kind of showing us about how confusing things are online. And so now, I just want to talk a little bit about, first of all, the background of what is embedded metadata anyway. So embedded metadata can be a lot of things, but one of the, it can use a lot of different schemas. A lot of people refer to it as EXIF data, but that's EXIF data really mostly comes from camera data or hardware data. So the IPTC created these standards a long time ago. So the IPTC is the International Press and Telecommunications Council, and I am a member of the Photo Metadata Working Group. But the organization itself was formed in 1965 by news publishers so that they could standardize the industry. But for more practical purposes, the IPTC has been defining standards for how metadata should be transmitted with images since the 70s, first with the wire services, and then once images start appearing in news outlets on the web. So there's a long history of this standard, but they have spent a lot of time and effort creating not only the standard, but also tools for users to do things like evaluate embedded metadata in workflows. There are interoperability tests, as well as the tool that I showed in this previous slide, which is called Get PMD, which is Get Photo Metadata, which is to get the IPTC photo metadata from an image. And you can call that from a browser or a desktop. I mean, from a browser or from an extension, rather. But they also created and have been running a test on social media platforms and on news sites to show which platforms retain metadata. And they've been doing this for a number of years. You can see this thing shows when it was last run, actually in 2019, and then before that 2016, and over time, sadly, this has actually become less and less valuable because of the reality, which is that, predictably, Facebook, Dropbox, Twitter, Instagram, all of these sites have stripped all of the metadata for years. Now, when you run the test now, Facebook leaves a few things in. They replace some other things. It always changes slightly, but for the most part, they pretty much do. They effectively turn all of our images into what's called orphans. They are orphaned because they are disconnected from from where they came from. Now, Flickr has actually done the best over the years at preserving metadata, and we'll see the value of that in a few minutes. But there have been so many, has been a lot of misuse of embedded metadata, and this is, primarily what's cited as the reason why embedded metadata has been stripped. A lot of people now don't like it because they've heard horror stories from, about, what the companies who collect it, are doing with it, but there's a lot of misunderstanding about exactly what is good embedded metadata and bad embedded metadata, and who the bad actors are that justify stripping all metadata from all images. I mean, privacy, especially around location data, is a real thing. There are, really bad actors, stalkers, and, bad people who will use location data badly. But, I feel like these bad metadata habits across the web kind of threw the proverbial baby out with the bathwater. We lost a lot in the way that, the habit on the web became just, oh, we don't need the metadata in the images. Let's just let it go. Let's not teach anyone about it. No, let's don't, make people more media literate in general. Let's just scare them, strip it all. And of course, originally people also cited reasons like, the file sizes and things like that, which, are legitimate in some developer environments, but it's a little bit hard to stick with that definition now that, we can see how much these generative AI, how much computing resources these generative AI companies are using. So it's a little bit hard to stick with that justification. But so I feel like this is a real key to a whole lot of things that could be improved about getting to real data on the web that is especially more precise about things that we really want to be more precise about. So here's some examples of that. Now, this again is a little bit hard to see, but one of the areas I was researching last year was to look at how to create better training data for machine learning. And so we were examining images from a data set called the Open Images data set, which was a huge conglomeration of images created by Google for the purpose of machine learning. And and a lot of those images came originally from a set from Flickr that goes way back over a decade ago, called the Yahoo Flickr 100 million images set. Now, fortunately, at that time, especially, Yahoo Flickr had the metadata attached. They left the metadata attached. They treated the metadata really well. And so machine description in general can be described as a tool that interprets the pixel data matched with captions and classifications. There's been a number of techniques how it's learned the captions, some from like alt tags and so on, and the classifications. But a lot of the way it interprets images is based on an evolution of machine learning techniques that have happened over decades. So what we're seeing in this image is actually that on the left were things that the human who created this image, his name is here, it's actually in the details tab, who the person was who originally created this image, I think in 2015 or something, and had it on Flickr. He has a list of his user tags in which you can see that this was at a hawk conservancy. It is a raptor, and it's a red kite, which is a type of hawk. But on the right here, you can see a number of just wrong machine tags: a sharp-shinned hawk, a red-shouldered hawk, a bald eagle, and also my favorite, a human head. So these are all passes that have been applied to this, whether it was, one pass by a machine learning process that was trying, machine was trying to, predict the classification. And, on the far right here, there's a field here for whether this was human verified or not. And the thing is that these annotations have been done over years by human annotators, who more than likely did not see the metadata from the original creator to begin with, but or they also didn't see it, get anything from a subject matter expert either. So we now have a history of techniques that have not only removed metadata from most of the image on the web, but have also replaced good quality metadata with techniques and processes that not only contain bias, this is where the bias comes in, but also potential to flatten the world down to common assumptions held by an average of annotators, not subject matter experts. So I also just have to throw in here that I get awfully weary when I am talking about very precise metadata with that's very context dependent. And like things like Porsche intake manifolds or whatever, and people will say, oh, but I say, when generative AI can't figure out what it is, and they say, oh, well, most humans wouldn't know the difference either, to which my response is, that's not the point. Some humans somewhere do know what this is, and we can do better at capturing this knowledge. So anyway, so this is the kind of work that I do, and the kind of research that I do is to study these kinds of this kind of phenomena and how this affects search, findability, reusability of images, and just really finding very precise images, and being able to hopefully maintain that for decades, to be able to not lose, to not start calling red kites sharp-shinned hawks when they're actually not, that type of thing. But I also want to say another thing about improving the quality of the web, and that's to say something about accessibility, and accessibility for low, blind, or cognitively disabled users. So I am a big proponent of the use of embedded metadata to improve accessibility workflows. And the IPTC standard does have a field defined in it for embedded alt text. which if more developers and more companies, especially social media companies, especially LinkedIn, the Twitters, the Facebooks, would just, if you could embed this one time and let it travel with the image, regardless of where you put it, including in an HTML page where it could also be transferred to the alt tag, because that is how it will be read by screen readers. So embedded metadata could do a lot for better workflows on the web in general, especially around accessibility. And finally, I think I'm doing still good. Finally, I just want to talk a little bit more about what we do with the tools that we create. These are software as a service tools. And one of these tools we do is we use linked data and ontologies to parse image description and keywords into URIs. So, this is some of the other speakers here have spoken about this today, about structured data and knowledge graphs, especially Ashley. I heard your talk, and it was a great talk about knowledge graphs. And so an example of this is that, by linking to public data sets like DBpedia, Wikidata, which is most of the one that people hear about these days, but it's all linked data, art and architecture thesaurus, custom vocabularies, and we use ontologies or just relationships. We can relate the image, which has a URI, to a linked data entity, and that linked data entity will also let it be found by superclasses or other more precise data that can be linked to the linked data entity. And so we can just build much more precise data sets that connect the image data, including copyright information, credit information, and anything else that is important to the provenance of images, to the image itself. And just for fun, we have had a little success with this, some little success stories. Here's the Porsche 356 1100cc intake manifold with the image snippets result as the top result for that. So at least the precision in the description itself, regardless of whether they are using schema.org data, so it all depends on how it's being used in these new algorithms, but we are seeing more and more and more of our index pages with the kind of precision that is helping Google learn more about what this type of material is. So I think that's pretty much it. I don't know how I'm doing on time, but you can contact us for consulting. That QR code is to donate to our research, which would be really great. And what's coming up in the future is we've got a client that we're working with in the cultural heritage sector. Woo! And that was kind of thanks to some networking behind the scenes of Joaquin. So thank you for that. And but please go check out image snippets and use our tools. That's about it. I hope anybody's going to have questions.
I just like to say, well, Haiti Araya, she's saying, never knew all of this. Very interesting. Thanks for sharing. I learned a lot. This is a very, it's not spoken about enough because, like you said, a lot of these things have been stripped, and it's not top of mind for a lot of people.
Right.
When they're developing commercial products or things like that. People are more focused on tangible things like text, rather than something that is kind of like hidden behind a digital asset. But I really enjoy watching you present, especially when you get into those moments of passion where you want to express the foolishness of stripping away these context-rich aspects of the metadata of these assets. I mean, the whole point of the internet is to pool our intelligence, not our ignorance and foolishness, right?
Exactly. It's like the information has been there. I mean, a system like Flickr, preserved that information originally, and then the other social media companies came along and just let's obliterate it. And they have some, there are some real privacy concerns, but I feel like, one of the platforms I often cite is like iNaturalist. They have a great way to let you specify the opacity of your location.
Yeah.
So you can either say, no, I want my actual real location completely turned off, or I'm not going to tell you my exact GPS coordinates. I'm just going to tell you I was in like the South UK, or something, or I was in London more generally, and so you can have like a level of opacity. You don't have to tell exactly where you are. I think that they just sort of got rid of a lot of knowledge, a lot of things that we could now access, and that by just sort of wiping it out. And I think Google now really genuinely wants to go back to using embedded metadata, but they're not even using it themselves yet in like with their Google Gemini tool. So it was kind of curious. It's always curious to see, you test it every day, like who's doing what now with what.
The same kind of problem that we're encountering here with image metadata is very similar to the problem that hospitals have with their sensitive patient data. You want
Mhm.
to strip away the personal identification information, but you also want to be able to aggregate population health data so you can uh, help create campaigns to educate people. All right, consume less sugar, consume more vegetables. There's a deficiency of vitamin A or vitamin D in this group. We
Yeah,
should do these things. Get more cancer screening earlier on because this population is at risk and we can catch it early. Uh,
right.
we need all
Right.
of this.
There's ways to retain the really good stuff. And the thing that I get very passionate about is that we've really had these techniques for decades. We've had the ability to do structured data better for the amount of effort that's been put into, like, let's throw out all the metadata and then do machine learning using substandard. I'm not calling the annotators themselves substandard,
No,
I'm calling the
but
techniques
but they're not they're
substandard.
not they're not all subject matter experts. There might just
Right,
be
they're not subject matter experts.
some
So
person
what
that is.
things, I mean, it's great if you can find, do a search for tiger, you'll get, tiger illustrations, thousands of tiger illustrations. That's not normally what people are looking for. Botanists want, I want to find this one botanist from 1892, and I want to see this one species that she found, and I want to, and I want to find, the original document where she found it. And this information is on the web, but instead we get
Can't
just
find it.
confusion, made up things. I think I'll just generate an AI image for it for your search result. Yeah. So yeah, so very passionate about it. But thank you for having me talk. I don't know how we're doing on time, but I think we did pretty good.
Yeah. So yeah, I always appreciate collaborating with you, and we're gonna be tuning in for the next one. We're gonna take a short break, and then we're gonna go on with Haiti. Haiti's gonna help us learn what we need to understand to navigate this AI landscape and upskill to be part of this growing movement, growing technology movement. So,
Great. Thanks
thank you,
so much.
Margaret.
Thanks so much, Joaquin. Bye
Bye.
bye.